Right, so now Felipe and Anne are going to present the sound of lambda, which promises to be a lot of fun.
Okay, let me just put my password here.
Used to be on mic out.
Okay, so hello everyone. Thanks for coming. Thanks for being here. I'm going to present you this paper we submitted, and it's called the sound of lambda, and it's mainly about how we implemented lambda calculus in the code clavier, which is a system. And Veinberg here, and myself. I've been working for the past 2 years, almost 3. No. Okay, false information. So here you go.
So just in the big scheme, everything is part of our code clavier. That's the project name, and because there's no piano here, so there's no confusion. This is always the setup. So there's a piano, a MIDI piano, ideally an acoustic MIDI piano, and that's what I'm playing on. There's no touching of the computer keyboard during a performance, and the code is projected behind, or ideally behind. So that's always a setup for everything we will talk about. So we will actually just give a bit of background to the code clavier project, what we've done before lambda calculus, and then we will talk about our C calculator, which is our lambda calculus calculator for the piano, and we'll talk about its artistic application, the way that we've been exploring it till now, and hopefully there'll be some time for talks about what we're planning to do in the future, and reflection and some questions from you guys. So with the code clavier, the lambda calculator, the C calculator is kind of the 4th version. We started off very basically just typing with the piano. Then we moved into looking at mapping musical motifs, so fragments, short fragments of music, and connecting those to code snippets. Then we combined the two so you could do a bit of both. And then we came to the C calculator. We're just going to play a short example of the earlier versions. There's plenty more on our website and the full version. So these little recordings are just kind of like to show you how it works. So it's very high-level coding.
And it is really simple. It's just mapping one key of the keyboard to an alphanumeric character, right?
Yeah. And not all the keys on the piano are mapped, so I try to accompany this with some general playing that goes on. So it's not that I'm just typing like this, but also trying to incorporate normal piano playing. But it's still very minimal in its pianistic sense. It's basically typing and substituting the piano keyboard, which is very easy to substitute. I mean, pianos have 88 keys, and you can get laptops with 88 keys too, so it's not a huge jump. But anyway, we felt that wasn't really exploiting the piano as an instrument, that was just kind of substituting the typing interface. So we moved on to motippets, and I'll play a short expert of this. Oh wait, this is the wrong one. Because I've jumped a slide, sorry. So that's your musical motive, and you get a larger snippet.
There was a little motive.
Yeah. The little motives allow you to control different parameters of the larger motives. And you can have multiple big motives and then multiple little motives, so you can be influencing the code on various snippets. And when it says the tremolo, that's the interval in semitones, so or MIDI number steps, and that is the variable that gets changed in the snippet. And what's very cool about this as well is that we could then, I can code in parallel, so I can code with my right hand and my left hand, and sometimes also in the middle, and be influencing different parts of different code all at the same time. We also used implemented conditionals in Multiplet, so I could set up different types of tests that were being applied to my piano playing. This is a short extract of that. So this one looks at if I play fast enough in the next 10 seconds. Or no, I said how long I play. So the image is, will I play 100 notes? If I do, I'll play the gong will sound in the next 12 seconds, and then it's counting. And I pass, and you heard a gong, but it's a bit distorted here.
So what we liked about this conditional thing is that until then it was just like really almost a silly mapping controller. And with this conditional thing we found out that by recognizing some of the motifs that can play, and they're mapped, let's say, to the snippet that defines a conditional, she could then say like, okay, I want to make a conditional, and then she could use whatever motif she wants from a database of result snippets, let's say, to say, okay, this conditional, if it evaluates to true, I want this to happen. And it follows this, and she could do that as much as she wanted and be changing the results that would be evaluated when the condition was passed or not. So we were getting steps closer to allowing her to program, to live code.
But the biggest issue is that all the code snippets for Super Collider, this is Super Collider, sorry, it's for the dirty Super Collider. They're all predefined beforehand. So you can have a huge amount of them, but they still have to be constantly predefined. And then we thought, well, how can we get closer to programming? And Felipe fell in love with lambda calculus.
Yeah, so how could we get away from this kind of rigid, just mapping and redefining and be more declarative in what we do? And that's of course when we came out with this, and we thought okay, we have to look at everything from a higher level of abstraction. So not just look for the motifs and this kind of pattern matching, but more okay, try to see what's a pattern, try to see what's a computation even, try to understand numbers, not take them from granted as we were doing, but actually realizing that they are functions and that everything is a function. And then also, as all of you have seen in the other talks in Farm, that you can also make functions for many aspects of music, right? So we thought okay, maybe this is where we need to look for if we want to bridge this gap that we have between playing the piano and producing code or meaningful code or programming. And well, you can read here what we're saying, but basically, for us it was okay, let's try to see if by abstracting certain aspects of piano playing, we can map that to abstractions of computation. And because it sounds complex, and it was complex, and it is complex, we said, okay, let's start very simple and go to almost the roots and make a calculator. All we want is just that you can add numbers, subtract numbers, multiply numbers, divide numbers, nothing, no negative numbers, no floats, only from zero and natural numbers, and also really basic built-in things to allow and to code more quickly. So we have successors, predecessors, identity, select first as true, select second as false, and of course function application. And with those we build the recursive functions to have arithmetic operations. And these were kind of building blocks. We also have, yeah, exactly. So here's how we did it, and probably some of you will recognize it. And you can judge it if you like it or not. It's not Haskell, disclaimer, of course. But to implement lambda calculus, this is enough. And on type. So what was interesting for us also is that, for example, while Anne is coding, sometimes she's playing really fast. We have to see how she's thinking. She can explain about it, but she could have done a successor of true. And that's not a number, but it wouldn't crash the system. It would just say, okay, that's not a number. So in a way, it helped us to also get the music flowing in a more intuitive way, and also translate that into code, and also help her to find a meaningful way to play music and get the expressions that were meaningful for making numbers and then making operations with those numbers. So here's the successor function, and you can see all of this in GitHub. It's all open source, and you just check out the CK lambda module, and then there's all the definitions that Anne is using. and we can show a little example, I think.
And of course it was mapped to the piano, so I'm just gonna, this is just a very basic example of how it was mapped. It's mapped only to B's, and that we did quite expressly, even though between the earlier versions of the code clavier we have many more ways of extracting functions from the piano. We thought to keep it really simple, and we'll explain that after the short demo. You may also notice that, for example, the note for addition and multiplication, as it for minus and divide, is the same, but it's looking at the articulation that I'm using. So if it's short, then it will be an addition, and if it's long, it will be multiply. So that was something that we implemented in terms of being better skilled at like recognizing piano inputs. And as a side note, when we first started playing, I only played B's. It was very boring. But having it limited to just one pitch all throughout the keyboard meant that I actually have a lot of tonal freedom in what I do with my other hand and the same time that I do with my other hand. And it also meant that when we implemented my ability to create functions, we could use a really interesting, we could create functions and my own tonal language as opposed to sticking to conventional tonal language and defining it from the beginning. So Felipe will explain more.
Yeah, I'll give a bit more of context on that. Like, if you see what you saw now, it was also kind of a very simplistic, maybe fun, but more like a quirky implementation of making arithmetic operations with lambda calculus on the piano. But the big discovery, I think, for us there was like understanding really how to make functions and apply functions and evaluate functions and pass functions, arguments, etc. And it opened then the door to find a way for Anne to define functions herself by playing the piano. So we don't need to define any motifs or snippets beforehand. Now Anne, in real time, can decide she wants to do a function and then start passing arguments from the built-in functions we have, successors, add, etc. And that way build her own more complex functions and then store them in the system, and then the system knows like, okay, there's a function C major. And then every time she would play C major, it would call that function, and then she could make a new function. So in that way, that's what she's talking about. She's making her own vocabulary live, making her own functions, and just doing this already, although we have these built-in ingredients, because it's lambda calculus, like it just can be extended or taken more low level, or I guess you want to say something.
No, I want to play the video.
Oh, okay.
So I changed by one note, which suggests I want to have one argument. By playing the collapsed pitches of the ostinato, so the chord.
So way more musical.
Yeah, and it really allows me to create my own harmonic language, which is something I'm really interested in. I play primarily contemporary classical music, which is pretty far away from Western tonal harmony. So it's nice for me to not be tied to tonic dominance and that sort of stuff.
Maybe you want to tell how you define the function? I don't know if that was clear.
Was it clear? So I play a four-note ostinato, so 4 notes repeated over and over. And once it registers, it says bound ostinato, and then by changing one pitch, by one semitone, I say that I want to make a one argument function, in which here it was with addition of 13 successors.
2x.
2x.
Yeah.
And x is taken from the stack, as you said. And you will see this tonight in action, so come along, and I promise it's a lot more musical in context. Well, I don't promise, but we try to make it a lot more musical in context. So that kind of brings us to the point, the artistic application of this, because this is fun, and maybe you guys would really enjoy it because you're lambda enthusiasts, but for the broader public, it's kind of a bit weird, including myself included. So we have two primary artistic applications. The first is obvsing the C calculator. Obvsing actually refers to our duo name. Before we started doing all this weird code clavier stuff, we used to just play around back from our conservatory time. Felipe is traditionally a composer, and I'm traditionally a classically trained pianist. So by doing this, we go back to that kind of format, and I'm playing the piano and doing the lambda calculus, and Felipe is live coding. And for doing this, he built special customized super collider classes, which are also available on GitHub. And what's exciting about those is that they take the values that I make with lambda calculus and are used in his code. So it's a really collaborative form of live coding. And he's going to explain a little bit how they work.
Well, there's not really a lot to explain. It's just like every time I make an instance of it, and I makes a number, that's sending by OSC the number, the value, or any Boolean value, which is saying true or false, or a non-number. I'm also storing the non-numbers, actually. And then I can use her values, the values that she's making, to apply them to different functions. Like in that case, I would get the number from one of the calculators, mapped it to the amplitude of the high noise. So that's how we perform this, and that's how we will perform tonight. More like me being in Super Collider and doing some stuff and trying to use what Anne is doing there to affect the code, which at the same time affects what I do next, etc. The other application we're doing is with augmented reality with Patrick Bourget from Germany. We actually just came from Karlsruhe. And what we thought is that, okay, we're using this calculator like this, so we can define then L system rules, which are like where certain symbols get converted to other symbols. Okay, so for example, she could define that number 1 gets converted to 2. That would be the rule, let's say. Yeah? All 1s get 2, and then by recursion, you grow a 3. That wouldn't be so interesting, but you could say 1 becomes 2, 1. And then it just grows a tree with recursion. But with a calculator, we said, okay, let's say that 1, you could make a 1, and then instead of making 2, 1, you make a 21. So she could just do it like that. You know, she could
do 3 by 7.
She would do 3 by 7, and she defines it quicker in a different way. Yet we're interpreting the numbers per digit, more like symbols.
Yeah, so this is a very short video made yesterday. To give you an example, this is really like what we're working on now, but we thought we'd give you a bit of a teaser in case you want to follow the project after. And it entices. Yeah, so it's basically AR on top of the piano. Or and yeah, the AI is produced by the L systems. But yeah, if you're curious, there's more on our website about how that's going.
We have 5 minutes, Miss.
We skip the future, it's in our paper, you can read it or try to read it. So I think the question we get a lot, maybe not from you guys, but is why are we doing this? And what can music really mean for programming? I think one of the biggest things is that music is about process, it's about the journey. And generally when you deliver code, you deliver something that is finished, and it's about handing over to your client a working product. And this is something really different. It's really much more about the journey. It doesn't really even matter if your AR visuals look a bit weird. The fact that you've been on a journey with it is something that really changes the way you're thinking about programming. I think something for me as I play, the programming that I'm doing, or the lambda calculus that I'm doing, it is very much also comes from how I play. I think, Donya, you mentioned this briefly as well, this idea that musicians were very dependent on muscle memory and this idea of what feels comfortable under the hand, and that also impacts then your programming.
And I would say we're also interested to see, like, if just by programming, by making music, what kind of processes are going on there, if there is such a thing as intuitive programming.
Yeah, because ultimately it's a big feedback loop between music and programming. You have to be thinking about the music when you program, and you have to be thinking about the programming when you're playing the music, and it doesn't always go, one kind of thought process always kind of takes over, and it's not necessarily clear which one at the same time.
And that's the glue.
And that's the glue. Okay. Screen of death. The other big part of the Code Clavier project in general is we want to look at what sort of art or music can we, what sort of...
like nowadays, we use technology to create art, right? You could see it with the AR thing, for example.
Yeah.
And we want to see if with these kind of approaches, we can shift that idea and see, like, okay, what kind of technology can you create with art, or in this case, through playing music? What kind of programs you end up making?
It's very ambitious, and ultimately, even more ambitious, can we bring a musical paradigm to programming? Ooh, and on that lovely note, thanks for your time. We hope to see you guys tonight, and then you can hopefully hear it, the C calculator in Ovsing in action.
Thank you.
Concerning the way art can feed the science and technology, there is somewhat a simple answer that I'm generally giving. As a researcher, I have essentially no idea all this work, plane control or nuclear plant control, why I do have some idea what music is. So to have idea on how to program in time, I have better idea trying to program music than to program nuclear plants that fortunately I will never approach.
So I'm wondering for your playing and programming, do you often want some kind of undo or backspace like I do when I'm programming?
Well, with the earlier versions, I did have a backspace. With Lambda, I don't. And yes, it gets me into trouble. But fortunately, there's not really much, there aren't really serious repercussions of my, with the C calculus. I'm sure with the bigger, like if I was doing hardcore Lambda calculus, there would be. But it's something we discuss a lot, whether I'm like, yeah, maybe we can have a clear function or a backspace function. Especially when I'm doing lots of successes. I mean, no, I can't keep tab of this because there's like rows of 3. In the AR, Felipe did finally give me a clear function, which I really appreciated. We think if you play a piano performance, you cannot go back and redo something. So that is also something that from the musical paradigm that I think maybe is worthwhile keeping, and it's just the way it is. But of course, if it would mean that things start really crashing, then we'd have to do it. But for this, it's not necessary.
Did you try reverse Polish notation for your arithmetic expressions? I guess it would cause you to make type error less often, so nonsensical computation less often, and also it would probably give a sense of rising tension when you put things on the stack and then release complete or partial. Might give a different feeling to the...
Yeah, we're thinking that one of the where we want to go eventually is also start including types and making more types and trying to see if that will then help the programs be more meaningful, avoid the expressions that don't mean anything, and as you say, we're stacking all those, see what happens when she evaluates the whole stack. We're definitely going there.
The buzzword is reverse Polish notation, right?
Okay, thank you.
I would say I would recommend not having a delete function, because as an artist I like making mistakes because they can lead to more interesting results.
Yeah, absolutely. We don't have one.
Yeah.
It's
I'm
just
saying don't make one. It's good without one.
Well, I think it depends on the context, because if you can really, if the repercussions are really gigantic, and remember I don't have access to a physical computer whilst I play, that could be really quite catastrophic. But when it's possible, we don't have it, and yeah. And in the early versions, we do have a backspace, and the thing is, it's still a note. So when you play a lot of backspaces, you also make it musical, and then it's a little bit like, is silence part of the music, or is going back music? So.
And there is a lot of backspace then, right?
Not always.
Just a comment actually, so I want to forward a thought I have from Chris. I think that when you do music in general, if you want to do art, you want to have some surprise in there. It doesn't have to be completely random, but there has to be some surprise in order for it to be interesting. But actually when you program, you want a program to be really, really boring. Like a good program is one where I look at it, I know, yeah, it does the correct thing next. But music is not like that, so maybe there is some interaction. I don't know, maybe Chris has something more to say on that. Just thought.
But
You never play cold golf?
Sorry?
You never done code golf?
Cold golf. Yeah, but cold golf is not programming, it's art. I would say.
It's art, surely.
I mean, Felipe and I slightly vary about this, but I would say the point is not to really build a non-performative programming language. So it's always about the performance, and yes, things do happen that are ugly, and I think that's perfectly fine, and that's part of the aesthetic. When we started, we really called it live coding, and it is live coding. It's just that the live coding movement now, it refers to a very specific type of movement, so we've shifted a little bit away from that. I think it's not about making beautiful code. I mean, in the second version, in the third version, I'm making like, I think in the performance, 1,000 lines of code, just that goes in 15 minutes. So there's nothing efficient about it. The beauty of the code isn't beautiful. Lambda calculus is beautiful aesthetically, but not from where I'm sitting. I think in its in its core.
One more.
So the last couple comments made me think, have you thought about doing a full forehand performance?
No, I'm not close to the idea, but
We'll have a disc here.
yeah, we have a disc cleaver version, but that's not really the same. I think it would be pretty.
People, is it?
Yeah, with two people, I think it's worth trying. Then I'd have to find someone that's first of all willing to kind of go on this journey as well, and I think it would be really tough to decide what you're building at any one moment. So that's like collaborative coding on a whole different level.
I mean, that's improvisation, right?
Yeah. I mean, it's worth a shot for sure, but.
Great, let's thank them again.